Hi, for this weekday's work as well as for the course final, I'm recording this video in which I'm going to describe regarding the model that I have used. So I am using the k-means clustering algorithm and I am designing that algorithm using the help of NetLogo. The data have taken is from the famous Kaggle website, and these are mall customers or the customers doing shopping in a shopping mall. I've used that data, in which we have the male, the genders, the age, the annual income, and the spending score of the customers visiting that shopping mall. So currently, I'm only using the annual income and the spending score. And I've done the normalization in order to have the data between a range of 0 to 1. So the data points, the data location is basically on the normalized values for both these columns, the annual income and the spending score. So first I'll describe a few things regarding the model. The first is the purpose and the patterns. So the purpose is to classify a data set which we do not know any any information regarding it. So we can classify the data set into clusters in order to find unique patterns in a data set. This is basically the purpose. The pattern is basically the for a selected number of centroids being found using optimization techniques. All the data points associated with a particular centroid will be at their closest distance with that centroid. For the entities, state variables, and scales, so I have used two entities. One is basically the data points, and second is the number of centroids. The coming to the state variables, we have age and gender as associated with each data point. However, I'm not using it for doing the clustering part for this project. There is another variable by the name of any centroid is moved, which basically tell that if the movement of centroids are still happening or not. If it stops, it means that we have reached the optimal state and the global minima, and we cannot move, we cannot. And the result is final. The clusters have been prepared. In the process overview and scheduling, so there are two sub procedures. One is basically the assign clusters, and second is the update clusters. In assign clusters, we assign a data point to the nearest centroid. And in the update cluster, all those data points that are assigned to a particular centroid, we take an average of them and assign that average as a location point to that centroid, so that the location of centroid keeps on changing iteratively until a point comes that there is no movement in the centroid, and that is the point where we can stop and we would be confident that we are able to find some patterns or clusters in the data set. Design principles, one is the objective of the model is to find clusters and patterns in a data set. Second is the emergence, which is a very famous important property. So does the calculation for the placement of centroids and the surrounding data for each centroid meet the three criteria for being emergent? First is it not simply the sum of individual properties? So the placement of centroids is not simply the sum of individual properties. It is calculated based on finding the data points nearest to each centroid, along with updating the centroid location using the mean of all data points referring to each centroid. Different type of results than individual level properties. Yes, the results are different because the data points have only one location property, that is the x and y coordinates. However, the placement of centroids dividing data into separate clusters is a different property than the mere location, that is an x and y coordinates of data points, and cannot easily be predicted from the property of individuals. Yes, we cannot predict the shape of clusters. The number of centroids also changes the size of various clusters as well. For the sensing and adaptive behavior, the k-means clustering algorithm requires all the nodes to associate themselves with the nearest centroid. The use of min1 of primitive allows to enable this property. The turtles on every tick will be executing the procedure, assign clusters and update clusters. These, and as I mentioned before, the assign clusters and update clusters will be performing those tasks. Uh, for the prediction, it is basically a sort of explicit prediction that happens here. The attributes, features of the datasets associate themselves with the nearest centroid by finding the Euclidean distance with each existing centroid. The agent keeps assigning themselves with the nearest centroid iteratively till the time the movement of centroids stop. Uh, and we know basically that at the end we are going to find uh, at the end there is going to be a minimum distance between a particular centroid and the number of data points associated with it. For the interaction, it is agent to agent interaction between the data points and the centroids. For the stochasticity, the initial placement of centroids in the dataset should be random, and this randomness is achieved using one of primitive instead of using any continuous or discrete distribution. Uh, for the plot, there are two types of plot which I'm going to discuss while running uh, the model. So if I do the setup, we are able to load the data, and here we have three centroids assigned. Uh, the on option here shows that the centroids would be assigned to one of the data points locations instead of being assigned randomly. Uh, it would be running 14 times. So if I do run the algorithm, so the algorithm is running, and as we can see, the centroids uh, they keep on moving until a point reaches with the stop, and that at that point the distance between that centroid and all of the data points is at its minimum, and we are able to find some interesting patterns clusters in the dataset as well. I have to run the data on the on minimum extreme values, that is minimum and maximum. So if I select the centroid number as 1, uh, so now we will only have one giant set, and it's not changing because we have only one node. And if I take it for example to 10, uh, then we would be having 10 clusters, so which like which also shows some interesting data, but as I'm going to tell now that how we are selecting the centronums. So this shows us that how what is the most optimal value that we should be selecting for the centroids, that is the number of clusters. So there is a behavior space experiment which basically tells us that how to select the number of clusters. So we select basically the point where the mean square deviation, which is the uh, mean of the sum of squares distance between a particular centroid and the rest of the data points. We select the point where an elbow is appeared in this graph, which is a graph between number of clusters. What is the mean square deviation? Uh, so since an elbow has a cut at 3, so we usually be selecting it. However, there is no general fast rule that we use. It basically depends on the domain of the data, along with some hidden trial method that allows us to select the number of centroids. Coming to the code part, so we have two major uh, functionalities. One is the assign clusters, and second is the update clusters. I have used undirected links as well, which basically helps to let us know these links between the data points and the centroids. And coming to the plots that we have, so here I have two types of one is the plot and one is the an output window. So this monitor or output window basically shows us the mean sum of squares distance with centroids, and it is basically not only the mean but the minimum of mean sum of squares distance with centroids, which is basically that after 14 iteration what is the minimum value where the mean sum of squares distance with all the data points and the centroids, what is the minimum mean value. So that is the my currency that I'm using. And in the plot we can see apart from only this or if I run it for 3 we'll be able to see it more better. Uh, so here we can see that for different iterations it is generating different graphs, which is basically a multiplication of square deviation multiplied the number of centroids. So as the square deviation decreases for each iteration, so here we can see that it sort of increases and then decreases. If I run it again, then maybe we'll be able to find a uh, more path in which we can clearly see the decrease in the square deviation, because the square deviation uh, decreases because the distance between a particular centroid and all the data points that keeps on decreasing with each iteration. So here we can see that for this pink colored cluster, it has decreased, and for the blue it has decreased. For the pink it has increased a bit and then got stable because we are using the sum of squares as the mean sum of squares. So since we are doing squares, so it has increased a bit. And so this is basically pretty much regarding the model. And so I've shown the design principles, the ODD, and the guidance for each ODD point. I have described that, and yes, I think this pretty much sums up the weekday work. Plus, I'm also going to use it for the course final also. Thank you.